He wasn't in a jungle. He wasn't at a dig site. He was in front of a computer, looking through forest data. Luke Auld Thomas, a PhD student at Tulane University, says he was on page 16 of a Google search when he opened an old file, a laser survey done by a Mexican environmental organization 10 years earlier to measure trees. Inside that file was an entire city, pyramids, connected plazas, a ball court, a dammed reservoir, more than 6,700 structures that no one had ever recorded. No expedition, no excavation, no machete. And the strangest part of this story isn't how they found the city. It's where it was. The place is Campeche in southern Mexico, at the base of the Yucatan Peninsula, Maya territory. Between the years 250 and 900 AD, some of the largest cities on the American continent stood here. Calakmul, just a few dozen kilometers away, was the capital of one of the two great powers of the classic Maya world. Then the forest came back. And the forest of Yucatan is a very specific problem for archaeology. The canopy is closed. A 20-meter temple covered in vegetation for 1,000 years looks from the ground like just another hill. From above, it looks like forest. For decades, mapping a city like this meant walking through it. A team could take years to record what a plane can now record in one morning. There's something else about this particular region. The strip around Xpujil was never considered a center of the Maya world. It's known for the Rio Bec architectural style, with decorative towers that mimic pyramids and for mid-sized sites. In the discipline's mental map, that was periphery. Land you passed through between the great capitals. And then came the laser. Lidar works like this. A plane flies over the forest, firing hundreds of thousands of laser pulses per second. Most of them hit leaves and bounce back, but a small fraction slips through the gaps, hits the ground, and bounces back from there. You discard everything that hit vegetation. What's left is the ground. And the ground of the Maya forest is a floor plan. In 2013, this technology had already delivered the biggest shock in modern Maya archaeology. A Guatemalan consortium funded the mapping of more than 2,100 square kilometers of forest in the Petén, at the heart of classic Maya territory. The results appeared in the journal Science, authored by Marcello Canuto of Tulane University and colleagues. More than 61,000 ancient structures where the maps showed nothing but jungle. Hold on to that number. It's going to come back. But there's a detail in that survey, and it's the one that matters here. That flight was aimed. It covered the region archaeologists already knew was the heart of the civilization, around well-known sites like Tikal and El Mirador. And this isn't a criticism. It's a budget. A LiDAR flight built for archaeology is expensive, and it's paid for by a research project with limited funding and a small footprint. If you have the money to scan 100 square kilometers, you don't pick that 100 square kilometers at random. You scan around the site you already know, where the odds of finding something are high. That's the rational use of the money. The side effect of that is quiet. Archaeology has been building a portrait of the Maya world with a camera that only ever pointed where the light already was. Old Thomas was after something else. His research question was whether lidar collected for other fields could be repurposed. Forest monitoring, carbon stock calculations, watershed studies, surveys that cost millions were paid for by someone else for a different purpose, and that stay public. That's how he came across a 2013 survey done in Mexico by the Nature Conservancy. The goal was to measure how much carbon was stored in those forests. No one on that flight was looking for a pyramid. The file was online, open access. It had been there for more than 10 years. And up to that point, no archaeologist had ever opened it. He downloaded the data and reprocessed it with archaeological methods. It's a job of subtraction. You strip away the forest and look at what geometry is left on the ground. Forest doesn't make straight lines. Forest doesn't make 90-degree angles. Forest doesn't make a rectangular platform aligned with another rectangular platform. What showed up on that terrain were straight lines, a lot of them. In total, more than 6,700 structures across the roughly 130 square kilometers covered by the survey. Houses, platforms, agricultural terraces, villages, and in the middle of it, a concentration that wasn't a village at all. 2 monumental cores linked by continuous occupation, enclosed plazas connected to one another, temple pyramids, a ball court, a reservoir formed by damming a watercourse, the kind of work only a large organized population builds and maintains, and a detail that dates the city without any need for excavation. An architectural complex of the type archaeologists call an E group, an arrangement used to mark solstices and equinoxes. That kind of layout points to an early founding before the year 150. That wasn't a settlement that had grown. It was a capital. Not even its name survived. The team named the site Valeriana after a nearby lagoon. And here's an honesty that most of the headlines cut. No one has excavated Valeriana. Nothing has been dug up. Nothing has been carbon dated. No inscription has been read. What exists so far is the shape of the ground, read by laser, and the interpretation of that shape by people who've spent their lives comparing Maya floor plans. That's a lot, and it's not much at the same time. It's enough to say that a large planned city with public architecture stood there. It's not enough to say who ruled it is who it traded with, or in what year exactly the last family closed the door and left. An entire city in high resolution, and not a single person yet. Now the part that changes the size of the story. Valeriana isn't buried deep in some untouched reserve, 3 days walk from anything. It's a 15-minute walk from Federal Highway 186 near the town of Spujil, right next to farmland. There are people living there. There are people farming there. There are people who drive right past it every single day. And here's the population estimate. At its peak, between the years 750 and 850, the city is thought to have held between 30 and 50,000 people. In building density, Valeriana ranks second only to Calakmul among the known sites of the region. Compare that to today. That same stretch of territory in the 9th century likely held more people than it does now. Old Thomas summed it up in one dry sentence. The government didn't know. The scientific community didn't know. Notice what that sentence leaves out. The people who lived there knew those mounds existed. The people who farmed there have been steering their plows around them for generations. No one who works that land thought those hills were natural hills. What didn't exist was the record. The city wasn't lost to the people. It was lost to the map. And it's worth saying that plainly, because the word discovery carries an old bias. A city of tens of thousands of people with stone pyramids right next to the only highway in the region was absent from every archaeological map until 2024. Not because no one saw it, because no one had written it down. But the finding that really matters in this work isn't Valeriana. Think about how that 2013 flight chose where to fly. It was planned to measure forest carbon. The criteria were vegetation, coverage, access, logistics. No archaeologist had any say. No known site pulled the flight path toward itself. In other words, as far as archaeology is concerned, that footprint is basically random. And that changes the nature of what you can conclude from it. An archaeological Lidar survey finds a city because it was pointed at a city. It confirms, it doesn't measure. A random footprint doesn't do that. A random footprint is a sample. And that sample, pulled from a patch of forest no one had any reason to consider special, came back full. Full of houses, terraces, villages, and a capital no one knew existed. Think about what that implies for everything else. The total area of the Maya lowlands is enormous, and the slice of it already covered by Lidar is small. Everything archaeology currently knows about Maya population density comes from that slice, and that slice was chosen decade after decade, precisely because known ruins were already there. When a sample chosen by accident comes back with the same result as the samples chosen by hand, you haven't found one more city. You found out that your counting method was biased from the start. The paper the team published in the journal Antiquity on October 29, 2024 has a title that reads almost like a confession from the entire discipline. Translated, it says, "Running out of empty space." Because the empty space on the maps was never actually empty. It was the space no one had looked at. The simplest explanation is that he got lucky. A PhD student, a long search, a click on a file that had been sitting there since 2013, and by chance that block of forest happened to have a Maya capital underneath it. That explains a lot. It explains why the discovery came from someone without the funding to commission his own flight. It explains why no one had seen it before. No archaeologist had any reason to go looking for archaeological data inside a report about forest carbon. But there's one thing luck doesn't explain. If Maya cities of this size were rare, the lottery should have failed. A random strip of Campeche forest should have come back with little to show for it. A few scattered platforms, maybe a village. It came back with more than 6,700 structures and a capital. Luck explains the timing. It doesn't explain the density. Here, it's worth flipping the question. Instead of asking what was found, ask what should exist if the old model were right. For much of the 20th century, the prevailing view was of a Maya landscape with scattered ceremonial centers and a lot of thinly occupied space between them. If that were true, something should show up in the data. Empty Lidar blocks, surveys that came back with forest and nothing else. Those empty blocks almost never show up. Every new large area survey in the Maya region over the last 2 decades has come back fuller than expected. Raised roads, agricultural terraces, drained fields, thousands of residential platforms in places classified as periphery. Remember the number I asked you to hold on to? 61,000 structures in the Petén in 2018. That study didn't just find buildings, it forced a recount of people. Earlier estimates put the population of the Maya lowlands during the late Classic period at a few million. After that survey, the authors were working with a range of 7 to 11 million people. A new technology didn't change the past. It changed the size of the error we'd been carrying. Absence is the data. What's missing from the record isn't evidence of a city. It's evidence of space that's genuinely empty. and it's almost never found. Now stay with me here, because this part is less about technology and more about people. If the count of cities is wrong, the count of people is wrong right along with it. And every time people talk about the classic Maya collapse, between the 8th and 10th centuries, they're talking about a scale. Emptied cities, abandoned construction, populations on the move. That scale was calculated using the number of settlements that were known. If that number was too low, then what happened there was bigger than what was calculated. This isn't about mystery. It's about the amount of human life that passed through that place and fell out of the record. Valeriana is the most direct example of that. A city with pyramids, plazas, and a reservoir. Tens of thousands of inhabitants, centuries of occupation, generations of people born, working, and buried there. Someone designed that reservoir. Someone decided where the main plaza would go. Someone carried every stone of that pyramid in a place with no wheeled transport and no pack animals. All of it was work, done by hand over centuries, and its name no longer exists. We call it Valeriana because of a lagoon nearby. It's a name we gave it last year because the name those people actually used has been completely lost. An entire city survived 1100 years under the trees, 15 minutes from a highway. And what didn't survive was what it was called. Luke Old Thomas didn't find Valeriana on an expedition. He found it in a file that had already been paid for, already published, and already public for 11 years. What separated science from that city wasn't jungle, or distance, or money. It was attention. So here's the question this whole piece of research leaves open, and it isn't about the past. How many cities are already sitting inside files that someone has already paid for, already published, and that no one has opened yet? If you were going to open one of those files today, where would you start? The forests of Mexico, the Amazon basin, or Southeast Asia? Write in the comments which region you'd scan first and why. This is Chrononum. We'll be back next time with another one.